Okay, question number 2 for these for the 2016 Practice FRQ. Question number 2 was one of those velocity problems, finding the final position and stuff like that. So they obviously give you the function for the velocity, and they state it. They also give you acceleration. Okay, so they give you two functions, velocity and acceleration, and they also give you the initial position. So this is the initial position, kind of like the starting point. Okay, so just some things to point out. For question A, you have to tell in the interval from time equals 0 to 5, when is the velocity of particle Q increasing? Give a reason for your answer. So the nice thing about this problem is that they give you the acceleration, and we know that velocity, okay, so if we're talking about increasing, we're talking about the derivative of velocity, and we know that the derivative of velocity is acceleration, and they gave us acceleration. So if it's asking when the velocity of particle Q is increasing, it's asking when is the derivative of the velocity positive, or when is acceleration positive. So let's just take that graph. Let's graph acceleration and see when is it positive. Okay, so here I have both functions typed in, y1, y2. Okay, and I have them both typed in because I realized that in the first video for question 1, I forgot to use that little bars trick. We can hit bars to make things a little easier. If you don't know what I'm talking about, I'll explain a little more in a bit. But now, real quick, make sure you're in radians. I forgot to bring this up also in that first video, so you always want to check and see that you're in radians. And since we're talking about tricks, let's say you accidentally graphed both functions and you didn't want both functions. So on the AP test, rather than wait for the functions to stop, to go all the way, you can hit second on, and it'll pretty much stop your function on its tracks. Okay, so rather than, if you accidentally graph a function that you didn't want on the AP test, you don't want to be waiting for it to all graph and then you can finally move around. You can stop it, hit second on, and it'll stop it. Now you can move and change whatever you wanted to change. Okay, just thought I'd show you that little trick so that you can use it on the AP test if you need it. But right now, I only want to graph acceleration, so that's the first function. I'm going to turn off that second function by clicking on the equal sign so that it's not bolded in black like this one is. See, y1 is bolded in black. y2, once I clicked enter on the equal sign, it's not bolded anymore. So when I graph it, only the first bolded function will come out, not the second one, because I unbolded it. Now, it's positive pretty much from 0 up until this intercept here. Okay, so let me show you how to find the intercept without having to graph y equals 0. So you hit second, trace, and you hit number 2, that's the zeros, that's the same as the intercept. So if you notice, it's asking you for a left bound, so I know that my intercept's going to be somewhere here. Okay, so a left bound is somewhere to the left of the intercept. You tell your calculator, give your calculator a left bound. So somewhere to the left of your intercept. So hit enter. And then it's asking you for a right bound. So go slightly to the right. Hit enter. time. And there it is, 3.963. Okay? So make sure you finish off with a good reason. Since the acceleration of particle q is greater than 0 on the interval from 0 to 3.963, the velocity of particle q is increasing on that interval. Okay, that'll do it for 2a. Alright, so for b, they want you to find the position of particle q at time t equals 3. So in your foldables that you did in class, I had you guys write this for final position. And I know that it didn't really say find the final position of particle q, but it kind of goes without saying that they're looking for the final position, especially if you know that at the start of the problem they gave you this initial position. Okay, so we're going to have to use that for part B. Okay, in other words, S sub 0 equals 2 here. That's what we're going to use for S sub 0. Okay, so what we have is 2 for the initial position is 2 plus the integral from 0 to 3 of velocity for particle q, that's a q, with respect to time. Okay, you can leave it like this. You don't have to write the function. Okay, on the AP test, you don't have to spend time writing the function 1 minus 3 cosine of t squared over 5. No, you can just write VQ of t. Set it equal, and then use your calculator for the rest to get your answer. So I'm going to put 2 plus math 9, so I can get the integral from 0 to 3. Now, remember that I was telling you about that vars tool? If you hit vars, which is the button to the left of the clear button, you hit vars, you go to y vars 1, and hit y2. I can see here that I say for y1, I have the velocity, the acceleration function, and in y2, I have the velocity. So for y2, I'm going to hit 2. So I'm going to integrate y2. So my calculator knows that y2 represents that velocity function with respect to x. Hit enter, and there it is, negative 1.490. So that vars option is actually pretty cool, and it helps you save some time. And if we just go ahead and leave this, negative 1.490, make sure you truncate around 3 places. This right here will give you the 3 out of the 3 points. Right here. Can you show this type of work? 3 out of 3. For part C, you had to remember a theorem. In order to answer part C, you had to remember the mean value theorem. And yeah, I know there are a bunch of theorems that we've discussed since August, and one student actually asked if it would be a good idea to make note cards for theorems. I think that's a great idea. That's a pretty good idea, because you can actually quiz yourself that way and get those theorems kind of embedded in your head. Okay, so for this one, you had to apply the mean value theorem. And here it is. This is what the mean value theorem pretty much states. Now, one thing that you really have to pay attention to is that you got to make sure that the function is differentiable and continuous. And in part C, they tell us that the function is differentiable. Now, they tell us a lot by saying that it's differentiable, because differentiability implies continuity. Okay? And make sure you don't try to flip it. Continuity does not always imply differentiability. So it does not work the other way around. If a function is differentiable, you know that it's continuous. However, if a function is continuous, you're not sure, you don't know if it's differentiable. That doesn't necessarily say that it's also differentiable. So that by this differentiable, we know that we can apply the mean value theorem. So we just go ahead and apply it. And this is how you would apply it. You just get the values pretty much directly from the problem that's pretty much given to you. So you just do a minus 4 over 3 minus 1, 4 over 2, and we get 2. And don't forget to explain. You have to explain. So you have to include that you use the mean value theorem, or that you apply the mean value theorem. And here's an answer. Or here's a possible answer. So since this function x is differentiable, which means x is also continuous, the mean value theorem states there is a value t for that interval such that the instantaneous rate equals the average rate. Remember that that's pretty much what the mean value theorem is saying. It's pretty much where calculus meets your previous math classes. The derivative, which is instantaneous rate, equals the average rate, which is the slope formula we used in your previous math classes before calculus. Alright, so for part D, we pretty much have to go back and gather some information about particles Q and R to determine whether these two particles are moving towards each other or away from each other. And we're going to start off by considering where they are at t equals 3. So what's their position at t equals 3? And if you remember in part C, they tell us that particle R's position at t equals 3 is 8. So we'll write that down. And now in part D, they told us that the velocity at time t equals 3 for particle R is negative 2. So that first sentence pretty much says a lot. Okay, so from that first sentence, we know that the velocity of particle R at t equals 3 is negative 2. Okay, so now particle Q. Back in part B, we actually determine the position of particle Q at t equals 3, and it's negative 1.490. Okay, so this goes for particle Q. This is going to be for particle Q. All right, and now all we have to do is calculate the velocity of particle Q at t equals 3. Remember, the velocity is given to us. Velocity is that y2 function. So vars y2. We'll go to the y vars, hit 1 for functions, and go to y2. So y2. Now this is just function notation. y2 of 3, and we get 1.681. And I'm going to explain this using a number line. So I have a number line here, and somewhere in my number line, 8 is over here, negative 1.490 is over here. So the negative 1.490 is the position for particle Q, and the 8 is the position for particle R. Notice that the velocity at t equals 3 for particle R is negative, so we go to the left. And the velocity of particle Q is positive, so it's going to the right. So they're going towards each other. Okay? So pretty much this left side implies that particle R moves to the left. The work here on the right implies that particle particle Q moves to the right. Therefore, the particles are moving towards each other. Okay? I wouldn't take too much time, actually I would not at all waste time drawing stuff on the AP test to explain yourself. They won't even consider this. If you would have drawn this graph, they wouldn't have considered it. Just make sure you explain yourself like this, and you'll be good. That's it.